We are starting 7E today, which is kind of a lot of information, quite honestly, which is why I provided you all of it kind of summarized together. We are going to need some colored pencils, so or highlighters. Highlighters tend to go through the page, so I'm going to have you guys think about using colored pencils. You'll need 2 different colors today, so take a minute and either grab 2 out of here. You can use yellow this time because yellow shows up nicely, but go grab 2 colors or use your own. If you have pens, that's fine. And then we're going to come back and talk about angles and intercepted art. So let's think about what the first thing asked you to talk, well, the first picture here is talking about what a tangent is. We're going to be looking at how tangents interact with circles today and how angles are formed by tangent lines. But let's look at this and let's come up with our own definition of what a tangent actually is. So I'm curious, what did you guys put? Lauren? I like that. It's a line that crosses at one point. Who wants to add to that definition? Anyone have a different one? Where is the line? I like that. So it's a line outside of the circle that touches or intersects with the circle at exactly how many points? 1. And that point is called the point of tangency. So I think you guys came up with a really good definition, so let's write it together here. So a line outside of the circle that touches it in exactly one place. I agree. We can clearly look, it is a line, it goes, forever in both directions. It has arrows. These are points of tangency. I'm just going to highlight them real quick. You don't really need to do that, but it just kind of kisses that circle in each of those places, each of those lines. Okay? Tangent line. Perfect. How about, oops, wrong way. How about a secant? I remember when I was in geometry in the dark ages, my geometry teacher couldn't say the word secant. She said secant. Drove me crazy. I don't know, things that happen when you're in 7th grade. Yes. Say that again. I love that. It's a line that crosses the circle in 2 places, yes. Who wants to add to that definition? Where is the line? What does the line do? Not only does it cross it in 2 places, but doesn't it cut through where? Cut through the middle of, not the middle necessarily, but the inside of the circle. Would you agree with that? So it's a line, again a line, it goes in both directions. And so it's a line that passes through the inside of a circle, not necessarily through the center, but through the inside, and it crosses, like Kiana said, in 2 distinct places, right? Good. So a tangent touches it in 1 place, right? And a secant touches a circle in 2 places. Perfect. So if you look right below that, you have a series of circles with some lines and some segments and some rays. And I want us to decide whether or not these things are secants, tangents, or just neither. So go ahead and write TS or N right underneath each of those. See if we really understand the difference between those. And then I'm going to have you guys come up to the board and write what you think. This, by the way, is correct. The neither is correct. This particular one that I'm talking about, this one, that's not a secant or a tangent. What is that? There's a name for it. It's a chord, yeah. And we'll talk about chords also today and how they look and interact in a circle as well. But my concern is with the one next to it. This isn't necessarily a tangent. What is this instead? Yeah, this is going to be a secant. And honestly, we had a good question come up over here about, do I have to have these 2 points necessarily drawn? No, they're assumed to be there if they're not necessarily kind of emphasized. So it is truly a secant. Okay? Excellent. So what we're going to spend the rest of class, Kelvin, shh, okay, We're trying to talk. I'm glad you're having a good time back there, but we're up here now. Thanks. So we're going to talk for the rest of class today about how secants, tangents, and chords, honestly, interact with the circle and that they form angles. So what kind of angles do they form? Well, real quick, before we get into the arcs that they form, I wanted to talk a little bit about the vocabulary quiz that you guys had last class, or a couple classes ago now. And I wanted to draw an example. See if I can draw it here fairly decently. All right, this will be good. All right, so let's look at this picture for just a second, okay? All chords and stuff in here, would you agree with that? They're all inside the circle. There's no tangents, there's no secants. All right, good. Really quickly, last class, we in the vocabulary quiz, we talked about something called a central angle. Do you guys remember what that was? Could you look up here and tell me a central angle? Yeah.
It's where an angle.
Can you name it up here? Use the letters. B what? B-E-C? Yeah, exactly. B-E-C. E is the center of the circle, right? So it has to be the vertex, middle point, right? B-E-C. And that's this particular angle right here, right? Where the vertex lies is going to be really important today. Vertex being a corner point. Question? Of course. I think there's another one. AED is another central angle. BEA is another central angle. Yeah, as long as E is in the middle, we're good. Okay, perfect. We also talked about something called an inscribed angle. And, oops, still in highlighter mode here. An inscribed angle is a little bit different. Where the vertex is with the inscribed angle is important. In a central angle, the vertex is the center. Where's the vertex in an inscribed angle? Mo, you want to go ahead, give me a name. Angle what? BAC, beautiful. BAC. Notice in an inscribed angle, where's the vertex of the angle? On the circle. That's real important for what we're about to go for the rest of class today, okay? Understand the difference where the A, where the middle point is, where the corner, where the vertex is of my angle. In an inscribed angle, it's on angle A. In a central angle, it's angle, excuse me, in a central angle, it's on the center, where the corner is. How do we feel so far, okay? All right. Now, these angles also form arcs. And we're going to talk about what is called an intercepted arc. And what I'd like for you to do is use your colored pencils at this point. It's kind of hard to tell because I didn't print it in color, which is why you're going to add the color. But go ahead and take your two colors. Pick one color for the outer arcs for me, like this. And then pick a different color to be the inner arcs. So just go ahead and just take a few minutes and just add that color, if you would, to your picture. Okay? Only for the intercepted arcs. Don't add color to the others. So as you're adding the color, I really want you to think about what the difference might be between arcs that are called intercepted arcs, and then look at the ones on the right that are not intercepted. Okay? Can we come up with our own definition about what is truly an intercepted arc? What are you noticing about the arcs and their location? Yeah. What kind of does out here too? Okay, so where are intercepted arcs? Well, they're on the circle, but in relation to the angle, where are they? They're on the inside. It's kind of like, if you think about it, the angle's kind of like eating the arcs. If I close the angle, they'd be on the inside. Can you visualize that, kind of, right? So if I was going to draw the angle, in each of these cases, and you don't have to do this part, but I'm just going to go ahead. Can you see that the intercepted arcs are all inside the angles? On the other ones, they're not. They're on the outside of the angles, right? So we're going to be focusing today on intercepted arcs. Hopefully you have an erasable pencil today, because I think sometimes it's helpful to go ahead and look at the angle, and then when we're done, erase it. So if you can kind of really see which arcs there are. So if you have a pencil that erases today, good idea. Let's define it. An intercepted arc is an arc. Remember what an arc is? It's part of a circle, part of the circumference of the circle. So it's an arc that lies on the inside of the angle. And these angles can be formed with tangents. They can be formed with secants, right? So either one, okay? So we're going to be looking at where the arcs are and where the vertex is. So if you look at your intercepted arcs, we have a couple of different cases. The first case that I see in terms of where the vertex is, this vertex is actually on the circle. Don't you agree? This vertex is outside the circle, outside the circle, outside the circle. The location of the vertex is going to be important. So what I'd like for you to do is I'd like for you to use your colored pencils again and try on the bottom to highlight in your two different colors where the two arcs are, intercepted arcs. So look at your four examples and go ahead and highlight where those intercepted arcs might be. All right, so when we're looking at highlighting here, we should have found an arc here, right? On the inside. We have an intercepted arc here, but there's another one. Isn't the one right behind it also an intercepted arc? Right? It's got, all it has to be is it has to be confined to be within the angle. Both of those are. All right. Then we have this one. Would you agree? We have this one. Am I done? Got another one, don't I, on that last one? It's like down here. How'd we do? We should be able to identify intercepted arcs, okay? Again, confined to be within the angle. Sometimes the picture is hard to see, and you might have something that looks like this. I don't know. I'm making something up. And I call this angle A. What arc does angle A intercept? So this is why sometimes it's good to use a erasable pencil. If I extended angle A, now can you see where the arc is? Do you see why extending it might be a little helpful? The problem is that you might be moving on, and maybe I say, well, what's angle B? And so you need to be able to erase it. Does that make sense? Okay, just wanted to show that. Good. All right, so go ahead and turn your paper over. Here's where the formulas are going to come into play. You should notice when you turn your paper over that you have 4 different sections, so to speak, of your paper, right? There are 4 different formulas, and it all depends on where the vertex of the angle is. If you look at the first example, it says vertex is on the on the center, right? Central angles. So we're going to write, and underneath each of those, you should see a blank, and that's where we're going to write our formula. And it's all going to be about what the measure of the angle is. So in each case, we're going to say that the angle measures equal to something. And it's different for each of the 4 cases. In central angles, the angle is simply equal to the arc measure. Now, I said arc measure, not arc length. Remember that arcs, this particular intercepted arc right here, is 32 degrees. Now it has a length where I could take a piece of string and wrap it around and measure the length of the string, but that's a different problem. The curvature of the arc is the measure, okay, not the length, the measure, degree measure. The angle is the same if it's a central angle as the arc. So what would x be here? X would simply be 32. 32 degrees. Nothing more, nothing less. Not trying to make it hard. Okay? It just is what it is. Yeah, this is for you. This is your notes. You're writing these down. It's up to you. Whatever's easiest. Whatever helps you see it. Yeah. Now the one underneath it's a little bit more difficult. So it's a little bit kind of bigger, a bigger puzzle, so to speak. Can you recognize that all of those angles are central angles? Where's the vertex? In the center, right? So I've got a bunch of central angles. But notice where x is. How can I find it? Lauren? Well, not 360, and it's good that you thought 360 because the entire circle is 360, but I don't have the entire circle. If you think about it, what is this? It's a diameter, right? So it goes through half of the circle. So rather than subtract from 360, let's only focus on the right side. So what should I subtract him from? 180. Good. So 180, and you guys have calculators. Go ahead and do that subtraction for me. Subtract 45 and subtract 80. It is. Very good. So x should equal 55. Double check him though. I think he's right. What do you think? Did you get 55? So 180, Sabellas, minus 45 minus 80. Okay? So sometimes it's pretty straightforward. Other times you have to kind of do a little bit of problem solving, so to speak. Okay? Any questions about central angles? Again, where the vertex is, where the corner is, right? That's important. We're going to skip the next case and do that last, okay? So we'll come back to this one. But let's talk about a different kind of angle that we already know about, and that's inscribed angles. Again, where is the vertex in an inscribed angle? On the circle. That's really important. And what I'm going to do is draw a, well, let's go back actually and look at this example that we did early on before we get to this. The difference between the central angle and an inscribed angle. Let's say that this is 50 degrees. What would the central angle be? 50 degrees. Can you see that the inscribed angle intercepts that same arc? The central angle and the inscribed angle both intercept. You see that? 50, that arc in the middle there. This arc intercepts both, or both angles intercept that. So while the central angle is going to be 50 degrees, the inscribed angle is going to be smaller. Can you kind of like take that, pretend like it's on a rubber band, and just take that vertex and pull it back? If you visually do that, doesn't it get smaller? How much smaller do you think it gets? If you had to take a guess. It's half. It is. It's exactly half. okay with formulas and where the vertex is in each of those angles? Feeling okay so far? The vertex can be in the center, it can be on the circle, or it can be outside the circle. Where the vertex lies is the biggest thing that matters. That tells you which formula to use. Okay? Let's jump down to go up to that next, where the vertex is inside the angle. These aren't secants and tangents anymore, are they? Up here, top right now. So, if they were shaded in like pieces of pie, I would agree. But because they're not in the center, they're definitely not sectors, we're really talking about chords that make arcs. So what I want to do is I want to take our colors again, and I want us to highlight the arcs that they're talking about. So just follow my lead here for just a minute. I'll show you what I'm talking about. So highlight those two on your paper. Let's highlight these two on the second example. And then let's highlight these on my last example. My smartboard doesn't like to make curves, but you get the idea. Okay. Can you maybe look at the picture and try to decipher why those are the angles I'm highlighting, or why those are the arcs I'm highlighting? That's where yes, it's where the numbers are, but it's also where the angles reach out to. Do you agree? So if you look at the first example, if I'm going to use my highlighter again, do you agree that those, pretend like that's a straight line. There we go. Do you agree that those two are like across from each other? Those arcs? Well, the other two, that's not what the angle is, though. You see how X is in there, too? So those are the two intercepted arcs with X, right? So the formula here is, again, the angle equals, and it is 1/2 again, and we are dealing with two arcs, but instead of subtraction, it's actually addition. And it's, I use big and little, but you can use outside, inside, you can use the two arcs, arc 1, arc 2, however you want to say it. What helps me remember that it's addition is because if I cross them, doesn't it look like a plus sign? If I look at the chords, it looks like a plus sign to me on the inside of the circle. That's a clue to me that it means plus in the formula. Okay? So make sure you realize that it's a plus, big plus, little. So let's use our formula for our first example. How do I write the equation to solve for x? What is the angle? X. So x equals 1/2, and I'm going to add two things. What two things, Sophia, am I going to add? You have your own little party lesson back there, all class period. Help me out. What two numbers am I going to use? 80 and? Beautiful. So I'm going to take 80 and 104, and since I'm adding them, it doesn't matter the order. I can do 104 first or 80 first. It doesn't matter. Great. So what's half of 184? 92. So this angle is 92 degrees. Well, yeah. It kind of looks like, so that you want to make sure your answer makes sense, right? And here it does. It looks reasonable. The angle does look like it's about right angle. I agree. Good. All right, what do you think about the second one? How am I going to start? 120 equals, good. The angle equals, awesome. 120 equals 1/2. Since the vertex of the angle is not on the center, because if it was on the center, wouldn't it be a central angle? So that's different. So So it's not on the center, it's somewhere else. So I'm going to add two arcs together. Which two arcs am I going to add together here? 180 and x. Excellent. This should look a little familiar to you. We're going to solve it for x. So what should we do here? Multiply by 2. We want to get rid of the fraction, right? Rather than distribute it. You can absolutely 100% distribute it if you want. And then you'll just have more fractions to deal with. Multiplying by 2 is a good idea. Gets rid of it. What's 2 times 120? 240. Is that right? So 240 is equal to 180 plus x. I don't have to worry about the negative sign, do I? It's kind of nice. But I am still doing what to both sides? Subtracting, right? So I'm going to subtract 180. And what's x equal to? Lovely. Awesome. Good. Again, where the vertex of the angle is tells me what formula I'm using. Okay? I have 4 choices here. The last one, a little trickier. So let's see what we can do. If you look at where the x is, it's not what I highlighted. I highlighted the arcs that I knew. So let's call this angle y. Can you go ahead and put angle y in there? Can I find angle y? Because doesn't angle y use those 2 arcs? It uses the 60 and the 200, doesn't it? So let's say I find angle y. What's the relationship between x and y?
Angle y equal x, right?
So then if I found this angle, then I can work backwards. I'm thinking outside for just a second. It's not a central angle. So let me think back just for a minute about this problem. If I say I want to find this arc, which means I need to find this angle, that arc, and that arc. Do you agree? This is a typo. I apologize. The only thing, we're not changing anything. We're going to make this a y. Please make this x that angle, not the arc. I think it was how it typed. It made it so it looked like it was supposed to be on the outside. But go ahead and move that x from the arc to be up with the angle. Okay? So now, what's the relationship between x and y? They don't equal each other. They make a line, don't they? So they add to be 180. They're a linear pair. Okay? Yeah. So let's go ahead, go back to our highlighting. I'm sorry that I erased that. Didn't mean to. So we had angle 60, and then the other one was angle 200. Let's find angle y first. So the angle is equal to 1/2. And what 2 arcs am I going to add? The 60 and it doesn't matter the order, because you're adding them. What's half of 260? Beautiful. Now 130 is not what we wanted, because that's y. We wanted x. What's the relationship between x and y? Perfect. So x is going to equal, beautiful. I think that one was kind of tough, especially because they're in the type. They add to 180. They're a linear pair, x and y. Because we moved x up to be the angle, right? It's not the arc. There's up to the arrow up by the x. Would you move it inside? Think about it. If I drew it bigger, maybe you can see it. This is y, this is x. They add to be 180 to make a line. Okay? All right, so let me pass some problems out for us to look at and try on our own. The first thing I want you to do is make a decision where the angle is, the vertex. Is it on the circle, outside the circle, inside the circle, or on the center?